Welcome to this lesson on finding the area of composite figures. Please make sure you have these notes in front of you so we can begin our lesson. And my students, let's make sure we update our table of contents. The learning objective for this lesson says I can find the area of a composite figure. The first vocabulary word is called a composite figure. And a composite figure is made up of two or more two-dimensional figures. So this is a composite figure because it's made up of two rectangles. And this is a composite figure because it's made up of a trapezoid and a parallelogram. So by putting multiple two-dimensional shapes together, you will get a composite figure. The second vocabulary word is to decompose. And decompose means to break down into smaller pieces. In this case, since we're talking about composite figures, we can break them down into smaller shapes or basic shapes. So for example, take this trapezoid that we have drawn. What I could do is I could go ahead and decompose this into two basic shapes. So now I have a rectangle and I also have a triangle. So if I wanted to, I could go ahead and find the area of the rectangle and find the area of the triangle, add them up, and I would get the area of the entire shape. So let's take a look at these different composite shapes and decompose them into basic figures. The first example is the bone. The bone can be decomposed into three rectangles. For the shoe can be decomposed into two basic shapes. The first shape that I see is a right triangle, and the second shape that I see is a rectangle. For the state of Oklahoma, the first shape that I see is a rectangle, and the second shape that I see would be a trapezoid. So all composite figures can be broken down into basic shapes. In previous lessons, we've learned how to find the area for rectangles, trapezoids, parallelograms, and triangles. So if you can break these shapes down into basic shapes, then you can find the area of these composite figures. So let's use these key concepts to discuss the following examples. So I just wanted to throw in this quick slide just to give you some more information about these problems. Alright, so if we're taking a look at the length of the black line, and I tell you that the length is equal to 10 inches, then we know that the length of the red plus the blue line would be 10 inches. But what happens if I said that the length of the red line was 7 inches? Then we have to figure out what the length of the blue line is. Well, I can say that the length of the blue line would be 3 inches, because 7 plus 3 gets me my 10 inches. Let's try another one. On the second example, I have the black line. I'm going to say that the black line would be equal to 30 feet. So that the blue line and the red line should also be equal to 30 feet as well if I combine them. So what happens if the blue line is equal to 15 feet? Then if I wanted to figure out the length of the red line, I would just subtract 30 and 15, and it would also be 15 feet. 15 plus 15 gets me my 30. So let's use these key concepts to discuss the following examples. For example 1, it says find the area of the figure at the right. The figure can be separated into a rectangle and a triangle. So let's decompose that so we can find the area of this entire shape. So by decomposing this shape, we can see that we do have a rectangle and there's a triangle on top. So if I find the area of the rectangle, the base would be 10 inches and the height of the rectangle would be 6 inches. So if I use the formula area is equal to base times height, the base of this formula would be 10 and the height of the rectangle would be 6, so the area of just the rectangle would be 60 inches to the second power. So now let's figure out what the area of the triangle looks like. So here's the triangle, and the base of the triangle is unknown. But if I know that the base of the entire rectangle is 10, and from this point to this point is 6, I will just have to subtract 10 from 6, so I know that the base of this triangle is going to be 4 inches. And the height is also 4 inches. So let's go ahead and use our formula. Area is equal to base times height divided by 2. Let's plug it in. The base is 4, the area is equal to 4, and we're going to divide it by 2. So 4 times 4 is 16, and 16 divided by 2 is equal to 8. So the area of the triangle is equal to 8 inches squared. So to figure out the entire area, I can take 60, which is the rectangle, plus 8 to get 68 inches squared for this entire composite shape. For example 2, it says find the area of the pool's floor. The first thing we should do is go ahead and decompose this shape into two basic shapes. One shape that I see, or the main shape that I see, is a rectangle. And the other shape that I see is a trapezoid. So we can go ahead and find the area of the rectangle and find the area of the trapezoid, add them up, and we'll get our answer. So to find the area of the rectangle, let's use the formula area is equal to the base times the height. So we know that the base of the rectangle is equal to 28 feet. And we know that the height of the rectangle is equal to 14 feet. So if I multiply those together, then the area of the rectangle would be 392 feet squared. So now let's find the area of the trapezoid. The area formula would be area is equal to the height times the quantity of base 1 plus base 2 divided by 2. So let's identify the information that we have. The height would equal to 2 feet. Base 1 would be 4 feet. And base 2 would be 6 feet. So let's plug this information in. Area is equal to the height, which is 2, times the quantity of 4 plus 6 divided by 2. So if I do the math, area is equal to 2 times the quantity of 10 divided by 2. So that would be 20 divided by 2. So the area of the trapezoid would equal to 10 feet squared. So what I have to do now is I'm going to have to go ahead and add the trapezoid and the rectangle together. So 392 plus 10 would give me 402 feet squared. So that would be the area of the entire swimming pool's floor. So pause the video, complete these guided problems, and we'll discuss the answers in class tomorrow. Notice there are two guided problems on this slide, guided problem A and guided problem B. So make sure when you're approaching these problems that you decompose these composite figures into basic shapes. For example 3, it says find the area of the figure to the right. So if you pay close attention to this shape, we've got two basic shapes, a square and a rectangle, that are overlapping. And whenever we find the area, we want to make sure we do not count the area twice. So the overlapping area should not be counted twice. So let's decompose this into basic shapes. I have a square here, and I have a rectangle here. So let's find the area of the square first. Area would be equal to side to the second power. And I know that one side of the square is 12 centimeters, so I'm going to say area is equal to 12 to the second power, which is just 12 times 12. So the area of the square would be 144 centimeters to the second power. So now let's find the area of the rectangle. Let's use area is equal to base times height. The base of this formula would be 15, so 15 is the entire base, and the height would be 12. When I multiply 15 times 12, I get the area is equal to 180 centimeters squared. So let's go ahead and combine them so we can see what the area of both shapes are. Let's take 144 centimeters squared plus 180 centimeters squared, and our total area would be 324 centimeters squared. So the area of 324 centimeters takes into account the overlapping area. And you want to make sure when you find the area, you're not finding the area of anything that overlaps. So we're going to have to take out the area that is overlapping. So we're going to have to find the dimensions of this overlapping region. So I know that the distance from this end to this end of the rectangle is 15. And this end to this end is 8. So this, from this point to this point, would have to be 7 centimeters. Because 7 centimeters plus 8 centimeters gets me 15 centimeters. So let's find the other dimension of the other side. I know from this end to this end is 12 centimeters. So if from here to here is 6 centimeters, then this side also has to be 6 centimeters to make it 12. So I have another rectangle in there. So let's find the area of the overlapping region. So let's use area is equal to base times height. The base would be 7 centimeters. The height would be 6 centimeters. So the area of the overlapping region would be 42 centimeters squared. So now let's take that away from our total. I'm going to subtract 42 centimeters squared from 324 centimeters squared. And when I do the math, I get 282 centimeters squared. So you have to make sure you take out the overlapping region. So pause the video and complete the got it problem, and we'll discuss the answer in class tomorrow. So now that we've completed this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.